We're going to learn about DeMorgan's laws. DeMorgan's laws were developed by Augustus DeMorgan in the 1800s. They show how to handle the negation of a complex conditional. Like not A and B is the same thing as not A or not B. Not A or B is the same thing as not A and not B. Notice that an and is changed to an or by negation, and an or is changed to an and. So if you see not and, it's equivalent to an or. And if you see a not or, it's equivalent to an and. Java uses the exclamation point to indicate negation. Here are some equivalent expressions. So, not less than is equivalent to greater or equal to. Not less than or equal to is equivalent to greater than. Not greater than is equivalent to less than or equal to. Not greater or equal to is equivalent to less than. And not equal is going to create an or situation where something is less than a number or it's greater than. Because, for an example, if it's not equal to 7, it's either less than 7 or it's greater than 7. So here are some examples. A and B. Not A and B, it's kind of like distribution. The not goes to each term inside the parentheses. So the equivalent would be not A, and remember, a not and is an or not B. Here's an example with an or. A or B, if you negate it, you're going to distribute the not to each term. So you're going to get a not A. A not or is an and not B. Now remember, all of these things are boolean values. So a not true is false, and a not false is true. You're changing the boolean value. So here's an example. We have an expression, x is less than 3 and y is greater than 2. If we were to negate it, we would distribute this not to this less than, we would distribute the not to the and we would distribute the not to the greater than. So it would become x is greater or equal to 3 or y is less than or equal to 2. So let's apply DeMorgan's law to this. So you get this. These are the same. Both of these would come up with the same truth value. All right, here's an example. X is equal to 7 and y is greater than 3. Let's negate it. X is equal to not x is equal to and y is greater to. What would be the outcome? Well, it would be if x is less than 7 or x is greater then 7. That takes care of the x equal to 7. And then we got a or, because we changed the the and to an or, and then we get y is less than or equal to 3. And then, of course, after that, you have your executable code after the if. So this part here was the negation of x equal to 7. Not and is or, and not, and now this part is the negation of y greater than 3. Here's another example. If x is not equal to 0 or y is not equal to 0, what if we were to negate that? So we would get an if. So what is a not? A not, if you were to negate a negation, it would just cancel. Now a not or is an and. So let me find and. And this would be a y equal 0. And of course, after that, the executable code. So this part is a not equal to. The and is a not or, and the y equal to 0 is the not equal to 0. So two nots cancel each other. All right, so here's an example of an AP question. Which of the following best describes the set of all pairs of values for Boolean variables a and b such that parentheses not a and b equal not parentheses a not b? Now the best way to do this is to make a little chart. So we're going to do an A, we're going to do a B, and then we're going to do both of them true and see if this works out. See if this is a set that works. So this is not true is false, because this guy right here now, because this is false, this and is false, because with an and you're going to have both true. So this side is false. All right, so we have true or true is true, but not true is false. So in this case, do we have false equal false? So this guy, come on, this guy is a winner. So he's good. We're going to put an X, we're going to put an X next to this guy because he's good. All right, so he's a good one. Now we're going to do false and false. All right, we'll see how that is. All right, so let's go back to here. So not false is true and false. So this is false. This side is false. False or false is false. Not false is true. So the left-hand side is false and the right-hand side is true. So this one doesn't work. So let's go on to the next one. Let's do true and false. All right, so A is true and B is false. And we'll see if that works. So this side here, right here, not true is false. because this is false, we're going to talk about this later, this thing short circuits. It doesn't even look at B. Because you have an and, both sides need to be true. Since the first one is false, we're done. Okay? So it doesn't even look at B. So this side is false. All right? Now let's look inside the parentheses. First side's true. All right? True. A is true. So with an or, if the first one is true, the statement short circuits, which means it doesn't even look at B because you only need one true in an or to be true. So this side is true. So not true is false. So this side is false and this side is false. So this pair is a winner. All right? So now we're going to do, we did true, true, we did false, false, and now we get to do false, true, and see if that is right. All right, so we're going to make this side right here is not false, making this true. B is true. So the left-hand side is true because you have a true and a true. Now let's go to this side. We have a false. We're looking at here. A is false. B is true. You only need one true to make this whole thing true. So a not true is false. The left-hand side is true. The right-hand side is false. So that's not true. So we have two pairs that work. So A is not it. We have, does it say one pair? No, we have two pairs. So we got to look at either C or D. Two pairs in which A is equal to true. All right, in both these pairs, A is equal to true. All right, let's look at D. Pairs in which A is opposite of B. This pair, they're the same. So D is not it. So the answer is C. Two pairs in which A is equal to true. So this little exercise over here that we just did, this is what you have to do with DeMorgan's law to prove equivalence. You have to go through all the true and falses and systematically work out whether the whole expression is true or false. All right. So here's another question. What is printed when the following code executes when x equals 4, so x is 4, and y equals 3? So x equals 4. So that is false. So this is false because 4 is not less than 3. And 3 is greater than 2, so this is true. False and true, making the inside true. But it's a not. So not true is false, and because it's false, it prints the second case. So you have to put the values from the questions into the Boolean expression. You have to evaluate the Boolean value of it, and then you have to negate it. You have to do this very systematically. All right, so let's try this again. 4 is less, so this guy is false. Because the first one's false, and this is an and, I don't even have to look at the second one, because this Boolean expression is short-circuited. Because they both have to be true, so I don't even have to look at this. First one's false, making the whole inside false. But we have a negation. Not false is true. So this whole Boolean expression that's been negated is now true. So the first case is printed. And that's DeMorgan's law. You're going to have a worksheet to practice it. And next class, if you listen to this video, you'll be warned. Next class is a test review, followed by a test the following class after that. But the test is going to be open notes. You just got to make sure that you do all the review so you have the notes to use for the test.